In this video, I'm going to be working AP Pre-Cal Homework 5.2, which is all about inverse functions. And the first problems are kind of just, working with a table of values for f and f inverse. And I think what regardless of how I feel about it, what we need to do is we need to just swap the columns, basically. There's that one thing that you're not going to hear me say, but I'm going to just take the output values and make them my input values. And then the corresponding input value, right? The input value that went with y equals -10 over here was x equals -5. And then you see, all right, well, it's just going to end up being the same table, but backwards. Okay, so over here, output values are now my input values. And then input values, the outputs. -2, 4, 5, 7. And you see, this is kind of mindless. This doesn't really, have much to do with, solving the problems or anything. We just switch some numbers around. Hopefully we got some better problems coming for you. We definitely do. So, sketch the graph of f inverse on the provided axes. All right, what I'm going to do is I'm going to kind of just graph a couple of points. I think these 4 points should be good, and if the graph of the original function is linear between all of those points, then the graph of the inverse is going to be linear as well. All right, so first I'm going to say, all right, this is the point where x is 1 and y is 0. So if 1, 0 is on the graph of f, then 0, 1 will be on the graph of f inverse. Okay. I'm not going to keep that there because I'm not totally sure what direction this graph is going to head, but I'll go over here and kind of label these other points. That's -2 and +1. This is -4, 3. And this is -5, 5. No, -6. I must have miscounted. 1, 2, 3, 4, 5. No, -5 and +6. All right, so need to pull out the point. 1, -2. 3 and -4. And then 6, -5. So 2, 4, 6. And then we would go down by 5. Really totally still understand why a person would want to graph a function and its inverse on the same axes. Maybe I'll do it special, make it a line pen. But I know that we've got some multiple choice questions we're going to prepare you for. So that's why we're doing it. All right, now here's a little bit better line of questioning. So what's the domain and range for f? Okay, and we can see that, it's got these, I'm still on the shape-making pen. It kind of has this limited domain. Okay, so the domain is the x values that the function actually takes in, so that's over here at -2. And it goes up to 1, 2, 3, 4 right here. Okay, right on top, that's a pretty heavy grid. So it's from -2 to 4, and I might, yeah, -2 to 4. And in the range, it's kind of like the y coordinates, and I'm going to say that's 1, 2, 3, 4 is -4, up to 1, 2, 3, 4, 5, 6 up here. So -4 is less than or equal to y, which is less than or equal to 6. All right, for f inverse. Okay, well, the domain, that's all the input values to the inverse, are the output values of the original. I might not say -4 is less than y is less than 6, but you know me, I'm probably not loving the idea of x being the input variable for the inverse, so I'm just going to say the interval -4 to 6, right? And we could both be happy. The range is going to be the domain of the original, that'll be -2 to 4. What are the maximum and minimum values of f inverse? Well, if you think about the, values of f inverse, the outputs right there, they're running from -2 to 4, so the minimum is going to be -2, and the maximum is going to be +4. All right, now we're going to find a bunch of things that follow. So f inverse of 2, okay, so I go up to y equals 2, I find some graph and solve the equation, right? So it's f of x equals 2, x equals 3, so f inverse of 2 equals 3. All right, now f inverse of negative 3. I go down to y equals negative 3 and I search for some graph. I found it right there. Okay, and I know with certainty that that's going to be negative 1.5 because of the slope of that line segment. The slope is 2. That means every time I go over 1, the graph goes up by 2. Okay, so if I was going up from negative 4 to negative 3 by 1, I would only go to the right by a half. So we're solving the equation f of x equals negative 3. That gives me x equals negative 2.5. It's not even right. No, that's going to be x equals negative 1.5. I feel like we know the equation of that line. That didn't quite look right. All right, f inverse of 1. We're solving the equation f of x equals 1. So it's going to be right here. And have this intersection point, and it's saying, okay, I went up 1. Okay, let me think about how I want to explain this one. All right, so if you look at this particular line segment, the slope is going to be rise over run is 2 over 3. So, and since it goes through the origin, the equation would be y equals 2/3 x. And you could solve the equation y equals, or 2/3 x equals 1 with y equaling 1. I think that would be a very algebraic way to do it. But you could also say that it's going to be, okay, each time I increase x by 1, y increases by 2/3. Oh, wait, no, that would be solving backwards the same thing. Either way, it's going to be 1.5. I don't really care how you arrive at that conclusion. I need you to be able to somehow reasoning with the slope, but it's definitely not the most important thing for AP Pre-Cal. Though I don't want you to get the wrong impression there, but it's something that we're going to need to be able to do in calculus for sure. All right, so f inverse of 5, we're going to solve the equation f of x equals 5, 2, 4, and 5 right there. And then we're going to need to find the x coordinate that corresponds to that point. And, right, so I'm going to say, all right, well, oh, yeah, okay, the slope is 4. You can't even really see that. Okay, but to go from the blue point to the higher black point at 4, 6, that's over 1 up 4. So it's a slope of 4. And so if I wanted to know how far I would need to go to get to 3, get up by 3, well, that would be 3/4. So it's going to be 3 and 3/4. Okay. F inverse of negative 5. Okay, negative 5, that's not in the domain of f, first of all. Okay, so we're not going to be able to find that. We're not going to be able to, oh wait, pardon me, it's not in the range of f. Okay. Now, it's true it's not in the domain, but that's not why we're not going to be able to find it, right? We're looking for input values that correspond to y equaling negative 5, right, if this axis were to continue. But there's no graph down here, right? I'm not going to be able to intersect any graph if I go side to side. So I'm going to say that this doesn't exist. You can say D and E, you can say it's undefined. Right, f inverse of negative 5. Well, I don't know why that would exist either. Let me actually think of a different value we can use there. All right. I like this one because it's going to use what we've already done. All right, so first we're going to start from the inside, and it's f of x equals 2. Remember, we already solved that equation right up there. Okay, so we're going to say that's equal to now f inverse of 3. Okay, and then we also, oh, we didn't solve f inverse of 3. I thought we did. We solved f inverse of negative 3. Okay, so that's going to be something new for us. F inverse of 3, that's where f of x equals 3. And we're going to solve that equation. Okay, and that's going to be right here. Right, and if I think about what x got me there, this is the part where the slope is 4. So to go up by 1, I would need to only go right by 1/4. So I'm going to say that's going to be, okay, if this is x equals 3, the x 1/4 to the right of 3, that's going to be 3.25, and so I'll say that's my answer right there. All right, then f of f inverse of negative 2, that's negative 2, because that's just how inverses work. But if we needed to like reconvince ourselves of that, f inverse of negative 2, where does that happen? At x equals negative 1. Then we're going to take f of negative 1, and we're going to go down and find the graph, and it's like, oh yeah, that's the exact spot I was looking at. output value is negative 2, the y-coordinate. All right. Now, here we've got a table of values, and I think, yeah, this one will be a little faster. So f inverse of 1, that's f of x equals 1. And we're going to find that right there. Okay, so that's x equals negative 1. And so f inverse of 1 equals, it's negative 1, right? It's the x value that gives us an output of 1. And g inverse of 0, that's where we're going to be trying to solve the equation g of x equals 0. And looking in the g of x row, I see it right there. That's going to be negative 3. Right, f inverse of 0, I'm trying to find where f of x is equal to 0. And that's right here. And so I'm going to report that. That's x equals 2. And then I'm going to move on. And g of g inverse of negative 2, that's going to be negative 2 because, first of all, that's how inverses work. But let me look at that. Oh, yeah, g inverse of negative 2, okay, that's 3. And then g of 3 is back to negative 2. Then f inverse of 2. We can't just say that's 2, right? It would be f of f inverse of 2. That has to be 2. But f inverse of f inverse, I mean, who knows what's going to happen with that. So f inverse of 2, first of all, that's 0. So I'm going to take f inverse of 0, and I think I already did that. Yeah, that was equal to positive 2. Oh, I don't like that. I don't like how it worked out that way. That's all right, though. That worked out only by coincidence, not because those two inverses undo each other, unfortunately. Okay, g inverse of 1. Okay, so g inverse of 1, g of x equals 1 right here. It's x equals 2. So I'm taking g inverse of 2, and so I'm looking for where g of x equals 2, and that's equal to 0. F inverse of f of 0, provided f of 0 exists, and it does, and I don't think we would confront you with this, like a got you type situation where it didn't. Reasons above, f of 0 equals negative 1, f inverse of negative 1 equals 0, that's what it means to be an inverse. G inverse of f of 1, all right, well, f of 1 is equal to negative 2. So I'm going to take g inverse of negative 2. Where's g of x equal to negative 2? Right there. That's x equals 3. All right, and then the last one, g of g inverse of 2. That's just going to be 2, and move on. All right, now here's where we're going to solve for the inverse. And I'm just going to remind you the 4 steps I told you about in class. First step, y equals f of x. Step 2, solve for x. Step 3, x equals f inverse of y. Step 4, substitute for x. Okay, now an expression for the inverse, I'm going to always stop and I'll highlight my preferred expression for the inverse, but we will go all the way to f inverse or g inverse or h inverse of x on these problems as well. All right, so step 1, y equals f of x. Y equals 3 times 2 to the x. Step 2, solve for x. Divide by 3. Take the natural log of both sides. I mean, not the natural log, the log with base 2 of both sides. Okay, and now I've solved for x. Okay, that's step 2 complete. Step 3, x is f inverse of y. Okay, and x is equal to log base 2 of 1/3 of y. Step 4, substitute x. So f inverse of x equals log base 2 of 1/3 x. And I'll tell you, I really think that an x equals a function of y is a really good expression for an inverse, but that probably isn't going to be what you see on the answer choices on like a multiple choice question. You're going to see that f inverse of x. So we need to be able to take it all the way, be able to do those last 2 steps. All right, d of x. I'm going to do this one. So y, I'm not going to label the steps anymore. In fact, I don't even think I forgot to say, okay, that was 3 and that was step 4 right there. But moving on over to this one, y equals 3 times 2 to the 3x minus 1 plus 1. And see, solve for x, that's y minus 1 is 3 times 2 to this power. This one's going to have a lot more steps. Divide everything by 3. Goodness. Yeah, this one's going to take up some space. Take the log with base 2 of both sides. And then I'm going to add 1 and divide by 3. So 3x is going to equal log base 2 of y minus 1 over 3 minus 1. And then I'm going to divide both sides of this equation by 3. And so I'm just going to divide the whole thing by 3, right? Don't make it too hard on yourself. So then x is f inverse of y, but I think I'm just going to skip that step and say, all right, f inverse of x equals log base 2 of y minus 1 divided by 3 minus 1. No, that's got to be a plus, doesn't it? Yeah. You need to add 1 to both sides, and that's kind of the danger in just switching sides of the equation like that. You make little sign errors. All divided by 3. And we aren't going to be doing, or not, I wouldn't say not able, right? Because we could use a log property and all sorts of log properties. We're not going to be wanting to do anything more with that. All right, g of x equals 5 times log base 4 of x. I like to look at this one a lot better. So that's y equals 5 log base 4 of x. And then I need to solve for x, not 1 over y. 1/5 of y equals log base 4 of x. And if I want to get rid of that log, I need to use an exponential. So I'm going to take 4 to both sides power. I'm going to say 4 to 1/5 of y is going to equal 4 to the log base 4 of x, and that's just x. That's the whole reason we did that. And now I've solved for f inverse of y. I would say that if you wanted to stop with an expression that gives the inverse, that would be 1. But f inverse of y would be 4 to the power of 1/5 of y, or 4 to the y over 5, however you like it. And then we can say, all right, well, that means f inverse of x equals 4 to the x divided by 5. All right, this one's looking pretty similar. It's just probably going to have a lot more steps in it. So y equals 5 log base 4 of x minus 2 plus 1. So it's like a 1/5 or a fraction or like a third or something for a change. So we're having all these, carry these fractions around. So y minus 1 equals 5 times the log base 4 of x minus 2. Yeah, just one step at a time. Then I'm going to divide both sides by 5, but I call that 1/5 of y minus 1 equals log base 4 of x minus 2. And just like on the last one, I'm going to resolve that log by taking 4 to both sides power. I'm going to say, all right, 4 to the 1/5 of y minus 1 equals x minus 2. Could add 2 to both sides and get 2 plus 4 to the 1/5 of y minus 1 equals x. And that would be an expression for the inverse. Okay, h inverse of x would be me substituting x. So 2 plus 4 to the 1/5 of x minus 1. Right. Y equals log base 3 of log base 4 of x. Okay. Maybe think about it this way. I'm going to use a stand-in variable, right? Let u equal log base 4 of x. Okay. Now I've got y equals log base 3 of u. And this might be a little easier for you to look at, right? Why I should work from the outside in. If I write it like this, then I think it's pretty clear that I need to just take 3 to both sides power here. All right, so 3 to the y is going to equal u. But u is equal to log base 4 of x. And so that means 3 to the y equals log with base 4 and argument x. There's the transitive property of equality. And so then to get solve for x, don't lose sight of our goal here. We're trying to solve for x. We're going to take 4 to both sides power. So 4 to the power of 3 to the y, that's going to equal x. And that's going to be an expression for the inverse. If we want j inverse of x, we're going to substitute with x. So that would be 4 to the power of 3 to the x. Really, really fast growing function. All right, c of x, 2 to the x minus 1 over 3. Well, this one will be a little easier, but this is a linear function, and those aren't always the most interesting to find the inverse of, but you know, we can find it all the same. Solve for x. Okay, and there we go. X equals 1/2 of 3y plus 1. Or we could say c inverse of x equals 1/2 of 3x plus 1. Or 3x plus 1 all over 2. However you like it. All right, y equals 3 to the 2 to the x. So I'm going to take a log with base 3 of both sides to get that thing down out of the exponent. So log base 3 of y equals 2 to the x. And then I'm trying to solve at x. Don't lose sight of what we're doing here. We're going to take the log with base 2 of both sides. Okay, well, on the left side, I had log base 3 of y. It's going to equal, remember, I'm taking the log base 2 of both sides. And I think it would be really easy to lose sight of that on this problem. And remember, log base 2 of 2 to the x, from the last unit, that's just x. Okay, so I've got myself an expression. And then I'm going to go over here and say h inverse of x, plug in x. Log base 2 of log base 3 of x. That's my inverse function. All right, and the last one of these is going to be y equals e to the 2x plus 3. Okay, so I'm solving for x. I'm going to take the natural log of both sides to get that stuff down out of the exponent of e. Maybe I'll subtract 3. And divide by 2. So I'd say x equals negative 3 plus the natural log of y, all divided by 2. The reason why I put the negative 3 out front is because like sometimes I'm bad about parentheses, right? I don't have any parentheses around the argument of my natural log. And that's fine as long as I don't have like log of y plus 3. If I have log of y and a plus and a 3, I don't have any parentheses, that's kind of ambiguous. And I'm probably not going to be able to give you the credit for something that you write like that. That's the type of presentation error we need to be more and more aware of as we start to think about the free response section of the AP exam for this class. Okay, but over here we've got all of that, and I'm going to substitute, no, not f, b inverse of x is going to equal negative 3 plus natural log x, all divided by 2. Right, write an expression for the inverse of the function on the given domain and find the domain and range of the inverse. Okay, great, like this. All right, so if we're dealing with an invertible function, it's either strictly increasing or strictly decreasing. So I'm going to find the range by kind of plugging in 4 and 9 into square root of x. I think you know square root of x is an increasing function because you get a bigger square root by putting in a bigger x. So I'm going to say that the range is the square root of 4 up to the square root of 9. But if I'm actually trying to compute the inverse, like solve for it, I rewrite that as y equals x to the 1/2. Okay, and think about what do I need to do to access x to the first power on its own. I would need to take both sides to the second power. So y squared equals the square root of x squared, so x to the 1/2 squared, and that's just going to be x. Okay? So f inverse is equal to y squared. Okay, so the input values I can put in are going to be, I'm thinking about, yeah, this one doesn't really have any like plus or minus type restrictions. So yeah, f inverse of y is y squared, f inverse of x equals x squared. All right, so the domain and range of the inverse for f inverse, the domain is going to be the range of f, and the range is going to be the domain of f. So 4 to 9. Okay, now the next one is the negative square root of 9 minus x squared. Let me get that next problem out of here. All right, let's maybe just think about, okay, 0 to 3. Maybe I'll start by solving for the inverse. Oh, okay, I see. We got some kind of meaning lost here, but I don't know if that matters. I have to think about this more. I'm going to square both sides, and I'd get y squared. Well, if I square that negative 1 right there, that's going to become a positive 1. If I square the square root, I'll just get 9 minus x squared. So I'm solving for x squared, so I'd say negative 9 plus y squared equals negative x squared. You could also say x squared plus 9 squared equals 9, and that will be a characterization of that function that we will be interested in later in this unit. So I was thinking, what else was I thinking about this? Oh, I was going to make it positive x squared by multiplying this whole equation by negative 1. Yeah, there we go. And then I will take the square root of both sides, and I'll say x equals the positive or negative square root of 9 minus y squared. And the question is it the positive or is it the negative? Okay, well, that question is answered for you right there already on the paper, printed in ink. I told you. X is between 0 and 3. Okay, so it's not any negative numbers. So I can just get rid of that plus or minus, and x is going to be the positive square root of 9 minus y squared. So I would say f inverse of x is equal to the positive square root of 9 minus x squared. And then, okay, well, if the domain was 0 to 3, this is what I'm not totally sure about, is if we're supposed to find the range of this thing, or if maybe, okay, because we know now for f inverse down here, the range of the inverse is the domain of the original. So that range has got to be 0 to 3. And yeah, I think about what, kind of what, I don't know, think about this. Basically, if you think about what happens at x equals 0, you take in the negative square root of 9 minus, oh, I see the issue. Yeah. Okay, so when I plug in 0 to 3, I think we do need to just find the range of the original, like this thing, and let that be the domain of the inverse, because without doing that, we really don't know. I'm starting to see it a little more clearly here. So when x equals 0, f of 0 equals the negative square root of 9 minus 0, so that's negative 3. And then when f is equal to 3, okay, the more x increases, 9 minus x squared just gets smaller and smaller, and it's going to be decreasing. So, yeah, and I'm taking the square root of something that's decreasing, that's going to be decreasing as well. So it's going to decrease down to 0. No, I mean, that was inaccurate, right? It increased to 0. So basically what I'm saying is that the range is negative 3 less than or equal to y less than or equal to 0. As a result, the domain of the inverse is going to be negative 3 up to 0. But that makes sense. You can put a negative number in there and square it and get a positive number back and take the square root of it. Yeah, no big deal. So, okay, f of x equals x squared. That's y equals x squared. Take the square root of both sides. Square root of y. Wait, plus or minus the square root of y equals x. Hey, is x equal to a positive number or a negative number? All throughout here, it looks like it's a positive number to me. So I'm going to say x equals the positive square root of y, or f inverse of x equals the positive square root of x. Okay, now the range of f, okay, if x is running from 2 to 5, x squared is going to run from 4 to 25. And then for f inverse, the domain is going to be the range of the original, 4 to 25. And the range of the inverse will be the domain of the original, be 2 to 5. All right, good. I see where this one's headed. So, like this, we'll start with the range. That might be wise. Let's plug in -8. F of -8 equals -8 plus 4 is -4, and I square that, I'll get 16. And then f of -4 equals 0 squared is 0. Oh, yeah, that makes sense. We're looking at the graph of y equals x plus 4 squared. It's got shifted left 4 units, except we're only looking to the left of that vertex. Okay, so maybe if you see the pattern, you see what's going to happen here, but I'm going to say the range is going to be 0 less than or equal to y less than or equal to 16. Then I'm going to say, all right, solve for the inverse. Y equals x plus 4 squared plus minus the square root of y equals x plus 4. X equals -4 plus or minus the square root of y. Now, ask yourself, is it the plus or is it the minus? Look at the domain of the original. It says -8 is less than or equal to x is less than or equal to -4. So x is between -4 and -8. X is definitely less than -4. So I have to be subtracting that square root. Okay, and I'll say x equals -4 minus the square root of y. So f inverse of x is going to be -4 minus the square root of x. And, okay, then I've got the domain and range of the original, so I can have, for f inverse, I'm going to have a domain of 0 to 16 and a range of -8 to -4. All right, now the last one then. Y equals, I should probably do the range first. I kind of liked that. Negative of x minus 3 squared. Yeah, let's do that range. All right, so f of 3 equals 0, and f of 6 equals the negative of 3 squared. So that's, remember, exponents before multiplication by -1, PEMDAS. So it's going to be -9. So the range will be, actually, I'll write that as an interval, -9 less than or equal to y less than or equal to 0. And because I don't have any issues with that, range of the original function is definitely wise. Then I'm going to solve for y. I'm going to multiply by -1. Okay, and then I'm going to take the square root of both sides, so I'll have plus or minus the square root of -y equals x minus 3. Now, that's kind of interesting, but it makes sense if we think, we can already know what the domain and range of the inverse are. Domain is going to be the range of the original, -9 to 0. So we're only plugging in negative numbers, so it makes sense for y that we're going to need to be taking the negative before taking the square root. Otherwise, we would be taking the square root of a negative number, which is not something we're interested in right now. So then the range is going to be the domain of the original, and that will be 3 to 6. All right, so I'm pretty much there. I'm going to say x equals 3 plus or minus the square root of -y. And I ask myself, what is the original domain telling me? The domain is 3 to 6, so this is 3 plus a number. Okay, because the square root of -y, that's still the positive square root, right? You just think about this square root. Whoops, I wanted a red pen. Red highlighter. The thing I put in red parentheses, that's a positive number, right? It's the positive square root. So I'm going to say x equals 3 plus the square root. And then I can solve for f inverse obtain f inverse by plugging in x, wherever I see y in the formula. I just said it and didn't do it. Plugging in x, substitute x. All right, now number 7. If g of x is log base 2 of f of x and g of x equals 4, what's f of x? Really, you could have done this problem in the last unit, right? G of x equals 4. 4 equals log base 2 of f of x. If I want to find f of x, I need to get rid of the log, so I'm going to need to use an exponential. So I'll take 2 to both sides power. 2 to the 4 equals 2 to the log base 2 of f of x, which is just going to be f of x. So I'm going to say f of x equals 16. All right, this one here, same story. I'm going to plug in g of x equals 3. Okay, take 3 to both sides power. Boom, we're done, right? F of x equals 3 to the third, which is 27. Okay, then keep it going. G of x equals log of f of x. Oh, yeah, if no bases shown, it's implied to be 10. So negative 2, but we can always write that in when we go to solve. Log base 10 of f of x. And so we will be needing to say, all right, take 10 to both sides power. 10 to the negative 2 equals f of x. 10 to the negative 2, that's 1 over 10 to the 2. Actually, I'm going to say over here, f of x equals 1 over 10 to the 2. That's 100. All right, now this one's a little tricky. G of x equals e to the 5/4. So e to the 5 divided by 4 equals the natural log of f. That's both base e. So to get rid of that natural log, I need to take e to both sides power. So I'll have f of x equaling e to the 5/4. And that's a really weird number, but that is the solution. That's what f of x equals. It's just a number. Really, at the end of the day, that is just a number that is not something you need to be scared of. And the last one we've got here is a construction scientist produced a model to predict the amount of cubic yards of concrete, C, needed to construct a parking lot with area A square feet. So if we're gonna give the construction scientist an area that we need covered, and like that, and we need to do this function f to it, or really I guess really it's c. That's the one thing about this type of problem I'm not sure about it. I get what they're going for here, but I feel like there's still something a little off. Okay, and it's giving us a number of cubic yards of concrete. So amount of concrete. I'll just write concrete. So C inverse would go the other way, and it would take in an amount of concrete and tell you how much area you could cover. So I had to pause and think about what it could be used for in a real life situation, but I think I came up with a pretty good one. Suppose you were doing a concrete job, and you had some left over, right? And I don't know, I don't think you can just take it home and pave something, but maybe you had a little bit extra, and you're like, hey, what could I pave with all this extra concrete? But basically, it's just a situation where you have an amount of concrete and you want to know how much you can cover. And that would be the meaning of C inverse. And that's the last problem on this homework, so that's going to be all for this video. Thanks for watching.